This is for Year 12 methods. It comes out of question number 6 in 5E, which is the changing bases and using the idea of transformations to explain them. Okay, so I've lifted from the textbook this little paragraph that helps me do it. So I want to go from y equals 3 to the x to y equals e to the x. Now, 3 is identically the same as e log base e of 3, because if you raise e to the logarithm of base e, it's going to equal whatever's in here, the answer. So I picked 3 because that's my base here. It's following exactly what was written there. Now, if I raise both sides to the power of x, then my equation is still correct and equal because I've done the same thing to both sides, which means 3 to the power of x equals log e to log base e of 3 times x, because when you raise something to a power to another power, you multiply the indices. Okay, so I can say that 3 to the x equals e log base e of 3 times x. So to this, if I was to replace x with x on log base e of 3, then I would have my right hand side becoming e log base e of 3 times x, and I'm replacing x with x over log base e of 3. My log base e of 3's cancel to leave me with e to the x. So 3 to the x becomes e to the x when you replace x with x over log base e of 3. Now I know from my transformations that if I replace x with 2x, therefore it's a dilation by a half from the y. If I replace x with x on 2, therefore it's a dilation by 2 from the y. So if I have this, which is what I've got in this case, if I replace x with x on log base e of 3, therefore it's a dilation by a factor of log base e of 3 from the y-axis. So to go from 3 to the x to e to the x, it's a transformation which is a dilation by a factor of log base e of 3 from the y-axis, which is what I've been asked to do here, 3 to the x to e to the x.